Hello, I am very pleased to be opening this week-long e-seminar on transforming teacher education to improve learning outcomes. This week, we will be exchanging perspectives with over 1,000 professionals involved in teacher education and educational policy issues from all over the world. I have been invited to offer a keynote address, drawing on my over 30 years of research and work on teacher education. I will be talking about transforming teacher education to improve learning outcomes. First, let me tell you a little bit about me. I am a professor in the Division of Educational Leadership and Innovation and the Southwest Borderlands Professor of Comparative Education at the Mary Lou Fulton Teachers College at Arizona State University. I'm an investigator and executive director of the Teacher Education and Development Study Mathematics, and for the first 5 years of mathematics teaching study. Designed to explore the connections between pre-service preparation and what is learned on the job during the first years of teaching. I am a former president of the Comparative and International Education Society, and my work involves the study of the effects of educational policy on school systems. Today, I will be discussing teacher education within the context of the SDG4. There are 3 propositions to my presentation. One is the proposition held by SDG4, the goal of ensuring inclusive and equitable quality education and promoting lifelong learning opportunities for all. Proposition 2 has to do with teacher preparation, which is recognized as key to improving the quality of education, as research has found that teachers are the most important school-level variables affecting student learning outcomes. And Proposition 3 teaches a complex undertaking and needs careful planning and implementation. Let me give you an advanced organizer for my presentation. First, I will outline the questions that will guide my presentation. And I will briefly present the results of a large-scale international study on teacher education as an authoritative source of evidence for policy. And third, I will outline recommendations for teacher education reform to ensure key competencies for teachers. The 3 questions that I will try to address in this brief presentation are: what can we learn about the strengths and weaknesses of teacher education systems from large-scale assessments? How and to what extent can teacher education systems be reformed to solve problems that are detected in learning assessments, on pre-service or in-service teacher education? And finally, what key competencies should be addressed through teacher education programs locally and globally, the goals of SDG4? First, insights on teacher education from large-scale assessments. What can we learn about the strengths and weaknesses of teacher education systems from large-scale assessments? To answer this question, I will use as my main source the results of the Teacher Education and Development Study, or TED-M. This is the first and only large-scale study on the characteristics and outcomes of pre-service teacher education in 17 countries. The study was funded by the U.S. National Science Foundation. It's a study that was sponsored by the IIEA, or the International Association for the Evaluation of Educational Achievement, and with support from the participating countries. And finally, I want to say that the views expressed here are mine, and they don't necessarily represent the views of the funders. So the Teacher Education and Development Study was a study done on the preparation of mathematics teachers, primary and secondary teachers. The study had 3 research questions to answer. One had to do with the policies that support prospective primary and secondary teachers as they learn to teach mathematics. The second question had to do with learning opportunities that are available to them via their teacher education programs. And the third question had to do with the level and depth of the mathematics and related teaching knowledge attained by prospective primary and secondary teachers at the end of their pre-service teacher education. So I will focus on the third question in this presentation, and that's a question that has to do with the outcomes of teacher education programs as concerns the preparation of future primary and secondary mathematics teachers. The Teacher Education and Development Study, or TEDSM, had important findings, and these findings indicate areas that need attention in teacher education programs. To highlight this now, and then I will describe the study and share with you some findings. In TEDSM, the programs that graduated the most knowledgeable teachers had entry criteria based on proof content knowledge. They also had a minimum required level of content knowledge, which was actually pretty high. So teachers had to demonstrate that they knew enough mathematics to ensure that they would be able to teach it. The programs also prepare future teachers as subject specialists. Is to learn the knowledge of the curriculum, including application and reasoning of important concepts. Had national or local standards that ensure future teachers' mastery of the knowledge of the school curriculum. And also had evaluation and accountability systems in place which help study practices and outcomes for continuous improvement. This was self-study, programs self-study of own practices. However, the most important finding was the benefit that teacher educators in the participating programs derive from engaging in doing research on their own practice and on how these practices impacted future teachers' knowledge to teach mathematics. Therefore, an important policy recommendation is the need for teacher educators to do rigorous and comprehensive longitudinal studies of their own programs in collaboration with their future teachers and with interdisciplinary research teams. At this moment, I would like to refer you to a document that will be shared by the seminar organizers. This is the international report from the TEDSM study. It could be obtained via ERIC, and the link is included below in this PowerPoint presentation. So now I will give a brief introduction to the study and share with you some key findings that will serve to highlight the important role of program evaluation research undertakings in teacher education. The study used 4 surveys. We surveyed teacher education programs, teacher educators, primary future teachers, secondary future teachers. These surveys included representative samples of teacher education programs and of their future teachers and of their teacher educators. So we can talk about national level findings. The survey for the future teachers, primary and secondary, was separate for each one of these populations, and we asked a number of questions having to do with their background, opportunities to learn, beliefs, and with and we included an assessment of knowledge of mathematics content, as well as an assessment of mathematics pedagogical content. I will only refer in this presentation to the results of the assessments of knowledge, but the results of the study, as I said, are in the international report, and there have been multiple publications out of this study. I will say that the data that we all collected is publicly available via the IIEP organization, which you can contact, and they will be happy to share the data with you. The study included representative samples in 17 participating countries. As you can see in the screen, we had countries from many places in the world. The data that we collected in 2008 included a large number of primary and secondary future teachers, and data from 500 institutions, including units preparing future primary teachers and future secondary teachers. And we also studied a large number of teacher educators. I won't talk about the teacher educators at all in this presentation, but as I said, the data is available in the report. As I said earlier, I will concentrate on the assessment findings. And what we assessed was mathematics content knowledge, or MCK, and pedagogical content knowledge, or PCK. The questions included questions on the content domains of numbers and operations, geometry and measurement, algebra and functions, data and chance. We also importantly measure cognitive domains. So what we wanted to find out in our assessment is not only what future teachers knew, but whether they were able to apply it and whether they were able to reason on these concepts. The curricular level knowledge, specifically the knowledge of school mathematics and university mathematics. For PCK, we content domains, but in the pedagogical domains, we measure whether they were able to engage with the curriculum in a way that will allow them to plan and enact effective lessons. I will only talk in this conversation about the MCK, or mathematics content knowledge finding. The instruments were rigorous. In other words, these were the assessments. For future primary teachers, we had 70 questions. For future secondary teachers, we had 49 questions. Most of the questions, 2/3 were of mathematics content knowledge, 1/3 was mathematics pedagogical content knowledge. And we had several kinds of questions, complex, multiple choice, a constructive response, and we had an administration time of 60 minutes. One interesting finding was that there is wide variation in teacher education across the world. There is not a single program to prepare primary future teachers. Rather, there are programs that we can classify as generalist, to teach to levels no higher than grade 4, generalists that prepare teachers to teach grades no higher than grade 6, and generalists, primary generalists that are prepared to teach no higher than grade 10. There are also, importantly, other primary programs that mostly prepare mathematics specialists for primary school. The secondary programs, we found 2 variations: programs that prepare lower secondary future teachers and programs that prepare lower and upper secondary future teachers. To report the results, people who are familiar with TEAMS and PISA assessments, you will know that the assessments are scaled to have an international mean of 500 and a standard deviation of 100. We use separate scales for MCK and MPCK for both primary and secondary future teachers. In other words, these were different assessments. And then we use something called anchor points to give conceptual meaning to selected MCK and MPCK scores. The number of anchor points were determined by the distribution of items along theta scale using IRT. Sorry, this is a little bit technical, but people who have worked with PISA and with TEAMS, I think it's important for them to know these, that we're using a similar metric. For MCK, or mathematics content knowledge, we had content experts review 2 sets of items for each anchor point. So basically, the anchor points are like benchmark, and we had items, and they're more difficult items. The easy items, or easier items, are represented by the anchor point number 1. In other words, those items that were answered correctly with a probability of 70, and the anchor point 2, the more difficult items, those that were answered correctly with a probability of 50. So these are some of the findings, kind of summarized here for you. So for primary mathematics content knowledge, future primary teachers did know a number of things. They were likely to answer correctly basic computations with whole numbers, understanding properties of operation, solving problems with fractions, and so on. But they had some difficulty answering items that ask them about solving abstract problems, understanding the number line, knowledge of proportionality and multiplicative reasoning, and reasoning about multiple statements and relationships about several mathematical concepts. So if you remember, when I described the assessment, I mentioned that we were not only interested in whether they knew something, but we wanted them to be able to, they could apply and that they could reason. So in reasoning, that's where we see the major challenge for future teachers in general. Now, for the items that are more challenging for primary future teachers, again, they were able to answer more challenging items like items on fractions, common multiples, determining areas and perimeters of simple figures, but they had difficulty with solving problems involving proportional reasoning or percentages, reasoning about factors and multiples, solving problems about area involving coordinate geometry, recognizing applications of quadratic or exponential functions, and algebraic reasoning. It's important to understand because when we look at the results of assessments such as TEAMS or PISA, when we look at what pupils are able to demonstrate, especially TEAMS, because TEAMS is associated with the school curriculum. What we notice is that the same kinds of problems that teachers have are similar to the problems that pupils have. So these problems with reasoning, these problems with making sense, are problems that are issues that are challenging for both teachers and their pupils. Now, this is a graph that shows the results, a summary of the results for future primary teachers. This is a small type here, but these tables and figures are in the report that I referred earlier to. So I encourage you to consult that report. I'm showing this to you because I wanted to let you see the difference between preparing primary mathematics specialists or preparing, for example, generalists. So if you remember, we had 4 types of programs that prepare future primary teachers: lower primary, primary up to grade 6, primary and secondary, and primary mathematics specialists. So when we look at the generalist teachers in Poland, for example, we see that they have, they score a mean of 456. Here is this line is the anchor point line 1. This other line is anchor point line 2. And we see that future primary teachers prepared generalists in Poland have some difficulty answering anchor point 1 items and anchor point 2 items. But if we go down the line here and we look again at Poland, preparing mathematics specialist group, we see that their mean is 614. And we see here that most of them are able to answer anchor point 1 items, and almost all of them, the average, are able to answer anchor point 2. So this is an interesting contrast, and it tells us that the way that one prepares teachers makes a difference. We see other countries that did score low, such as Georgia and Chile, for example. So now let's go and look at the performance of secondary future teachers in mathematics content knowledge. And as with their counterparts in primary future teachers, they are able to answer a number of items correctly, involving concepts of whole numbers, problems with algebra, problems involving geometrical figures. But they have difficulty with describing general patterns, solving multi-step problems with complex linguistic and mathematical relations, relating equivalent representation of concepts, analyze concepts. They have problems with mathematical reasoning, and they have problems recognizing faulty arguments and justifying or proving conclusions. These are all, by the way, skills that teachers need to have when they are teaching pupils about these concepts. Now, going to the anchor point, secondary feature teachers anchor point 2, or the more difficult items, again, we see that they are able to answer a number of questions. So people are learning. So questions about functions, particularly linear functions, quadratic functions, they are able to analyze and apply abstract definitions and notations, the new definitions and theorems taught in tertiary level courses, and so on, but had difficulty solving problems stated in abstract terms. They had problems with logical reasoning. They had problems differentiating the truth of a statement and the validity of an argument, an essential skill in mathematics. And they have problems recognizing valid proofs of more complex statements. So again, we go to the figure summarizing the results for future teachers, secondary teachers across all countries. And we see across the two program types, lower secondary and upper secondary, there are huge differences, very important differences. We see that the lower secondary future teachers, many had difficulty. The means are below 500. Answering the anchor point, even anchor point 1 items. Here's the anchor point 1 line. Teachers who did better were, future teachers who did better were those in Poland, in Singapore, in Switzerland. Then if we go down here, we see, for example, Chinese Taipei. Future secondary teachers did very well. In fact, they were able to answer all of the items correctly with quite a high average scoring. In contrast, we see Georgia teachers having difficulty achieving anchor point 1 and 2. Then we see Germany and other future teachers in other places. For example, the Russian Federation, they did quite well as well. So it does. So teacher education does make a difference, and the content, the opportunity to learn that teachers have when they are in the programs make an important difference as well. Again, I encourage you to go to the report so that you can read more carefully and in more detail. You know, the results of the study. Here, for the interested reader, there are other reports. I have provided the links here, but you basically can find all the reports in ERIC. We have a conceptual framework that explains how we did the study, how we planned it. As I said, the international report, and there is a technical report and also an encyclopedia that provides enough detail on the different programs. These are all the reports of the study. For your quick reference, they were published between 2008 and 2014. Go to the second part or the third part of my presentation. How and to answer the question, how and to what extent can teacher education systems be reformed to solve problems that are detected in learning assessments? Of course, this is a very, very complicated question, but short answers to the question, and I encourage people to engage in discussion about this. The TEDSM study and other studies I have done in different countries, not only quantitative studies, but qualitative studies indicate that teacher education programs need to be more selective. They should admit students who have a demonstrated knowledge of the subjects that are taught in the curriculum. Teacher education programs should prepare subject specialists for both primary and secondary schools, if at all possible. Teacher education curriculum needs to be designed according to global knowledge standards and should be closely aligned with the school curriculum. Teacher education needs to consistently use formative and summative assessments of knowledge and skills to map future teachers' progression toward desired outcomes, and programs should continuously research their own practice to promote self-improvement and maintain accountability. Another question having to do with teacher education reform is the question of whether the focus should be on pre-service or in-service teacher education. My research indicates that the answer is both. Teaching needs to be seen as a lifelong learning process. Pre-service preparation is essential to firm up the knowledge and pedagogy of the curricular subjects. If into programs not knowing the knowledge that they need to have in order to be able to teach, then programs should be able to teach that knowledge before declaring them as ready to teach. So pre-service teacher preparation is essential gatekeeper for this effective teachers. In-service preparation needs to address challenges teachers confront when teaching subject content of the school curriculum. And in a school, quality mentoring for beginning teachers has proven to be very successful in many cases. So in-service teacher preparation sometimes does not have anything to do with content, but the argument here is that knowing the content and how to teach it should be the key focus of in-service preparation undertakings. That mentoring should be key to this effort. And I wanted to make a point here that mentoring needs to be learned. So sometimes you have very effective teachers that are unable to be effective mentors. So mentoring is a learned skill. And then for both pre-service and in-service preparation, it is essential to support teachers as they learn to teach a curriculum to pupils that are in most need of quality teachers. So in teacher education, either pre-service or in-service, sometimes we make the assumption that all students are somehow similar, or teacher education assumes that teachers are going to learn to teach the average student. But in fact, the situation is that every child is different, and so teachers need to learn how to adapt teaching to the particular learning needs of all children. Addressing teacher competencies is another question that I was asked to address. So what are key competences? What key competences should be addressed through teacher education programs locally and globally to achieve SDG 4? For teachers of early grades, teacher education programs need to make sure that all teachers have basic literacy and numeracy skills and that they know how to teach them to children. Sometimes the assumption is made that because future teachers have undergone secondary or even high school education, secondary education, they know the knowledge that they need to teach. That assumption has proven wrong in many cases, and that's why the emphasis in this presentation that future teachers need to be assessed when they enter the program so that we know what they bring with them and we know how to help them before they even can learn how to teach that knowledge. So for all future teachers, there is an urgent need to improve their subject content knowledge, their subject content pedagogy knowledge, how to teach underserved populations, including teaching the coding skills for reading as a starting point, advanced reading and writing skills, and numeracy skills. Improve their knowledge of the school curriculum and improve their knowledge of assessments. In other words, how to use assessment results to improve their own practice and their pupils' learning. In conclusion, teacher preparation programs, whether pre-service or in-service, cannot assume that future teachers come to their programs with the needed content knowledge to be effective teachers. The ability of programs to ascertain via sensitive assessment and other means that future teachers know their subjects and that they know how to teach it to pupils. This is before they are declared as ready to teach. And I argue that this is a question of social justice. Pupils come to school expecting to be taught by effective teachers, and future teachers come to teacher education programs or in-service education programs expecting to become effective. Institutions have the responsibility to fulfill this commitment. I am very thankful for your attention to this presentation. You can find more information about me in this website. We are planning another study, not necessarily I guess, an IE study, but another study that will link together the outcomes of teacher preparation with the first 5 years of mathematics teaching. I will be interested in knowing whether there is interest from your part on participating in such a study. My email is teresatato@asu.edu. Again, thank you very much for your attention, and I wish you a week-long e-seminar on transforming teacher education to improve learning outcomes. Thank you.